Hi everyone, welcome back to the channel. Today what I want to do is talk to you about the removal of the inner pinion race and why we're going to need to get that out. Now on most other differentials, the pinion is shimmed for the pinion depth adjustment underneath this inner pinion bearing, but lo and behold it's not like that on this this Mercedes differential. The actual shim depth is the pinion depth is controlled by a shim that is underneath the race in the housing itself. First of all, when I found that out, I was chatting to Duke. It seemed like a bit of a pain to me, but in a way it isn't. Well, it is and it isn't. The one advantage, if you know anything about setting these pinions up on a traditional differential, a lot of the hassle that people run into is if they don't have the pinion depth correct, they have to remove their nice sparkling new bearing off of the shaft and then shim it differently, either thicker or thinner, depending on what they need. And obviously there's a risk of damaging their new bearing. Now there are some people, me as one, I was expecting, and I did actually order 2 inner pinion bearings, for the idea that I was going to sacrifice one as a setup bearing so it could slip on and off, and then I can make my adjustments and keep the new one in the box till the final setup and then just press it on and be done with it. But that's not the case. So that opens up another situation where we need to remove that race from the differential housing, but also keep that shim that is underneath there and not damage it, because that may have to come out and get pushed in depending on our results for the final gear pattern check with the paint. Let me get you in close and I'll show you what I mean and the problem that is ensuing from that. Obviously this is the outer pinion race here, and the inner one is on the inside here, which is obviously bigger. Now, what I've seen in many videos, and I'm sure you've seen it too, is someone using sometimes I think they use a softer metal like a brass and use a drift to drift that strike onto the race, or actually the shim, and tap it out gently. Now I can certainly do that, but talking to Duke and going by his experience, is a high risk of damaging that shim on its way out. So what I decided to do is try and make a tool that will remove that shim and race without damage, and be able to remove it and be able to pull it back in and remove it depending on what we need to shim. So first thought is that something has to get past this, which is smaller, over to this race and then strike it, and obviously that you can't do, can you? So let me give you an idea. Now on a basic level, you know, I've got loads of these discs, and these are for pressing in bearings, pressing in races and all that stuff. These aren't the specific race ones because they're not chamfered, but I figured these could work. But the trouble is, obviously, you're going to need a bigger one on the other side of this smaller one. So we need something to get inside here and open up and expand to be able to strike that race out. I've come up with an idea that we can not only strike it in one place, but we can strike it in 6 places at once. So that is what this video is all about, and I'm going to show you the materials I'm using. I'm not going to go all through the video showing you me putting it all together, because you can see the way it's put together, and we can discuss all the little details about it as we go. Simple things you can get in a hardware store. There's a 1/2 inch rod, threaded rod, which is what, 12 inches long, something like that. Then you've got, I'm going to use 2 of these. These are connecting sleeves. Now they're threaded, and it's essentially just like a long nut. They're normally designed to connect these rods together. So a couple of those. I'll have a couple of these 1/2 inch nuts. Got another one over here. One of those, okay, 2 of those, sorry. And a couple of washers. Now this flat bar is, let's see, we've got 1/2 inch, and that is an 1/8 inch thick flat bar of cold rolled steel. This can be had at any hardware store as well. The size of this is kind of, you don't want it too wide because of what you'll see in just a second. So what I did I cut this into 6 pieces, around 6 inches long, okay, 6 equal parts. I cleaned this up, ready for welding, and so what I'll do, I'll show you what I ended up with. Essentially, welded up, excuse the, no, so weld I guess, so 6 pieces welded on to one of these guys. I did the 3 first, ground it flat, and then came in with the other 3 and just made it fit. Okay, so, and then I kind of welded up the end of it here as well. So I think you can probably see where I'm going with this. So these ends, these finger ends, have to be all at exactly the same length, okay? And I'll get into talking a little bit more detail on the ends of these in just a second. Anyway, so I'm going to stop the camera a sec while I thread this on. That's threaded on there, okay? And then this is a lock nut that I bring into place around about here. You're going to have to adjust this when you use the tool. So that gets set just like that. Then what I've got here is just a standard washer, and I've chamfered the edges slightly, just chamfered them to help it go in. And also you could put a little lubricant on here, a little oil as well, just to help it on its way. So this guy goes in there, okay, and you might have to pry these fingers open a little bit just to get it started, okay. So you get that in there. And this, depending on your application, you can use longer or shorter bushings or add bushings. That little brass bushing goes in there. And then I'll put another one of these guys there. Let me just accelerate this. So you can see what's happening. As this goes down the shaft, it spreads these fingers, essentially making it bigger. So this is going to enable me to insert it inside the smaller outer race, and then once it's past that point, we'll just open it up. So this is only part of the tool. Obviously, once this is inserted, well, you know, a couple of things. What you could do, you could start whaling on it and use it just as a regular old drift, but wanted to add to the ability or add to the surety that that's not going to just slip off, okay? So I made this guy. This is just a very thick pipe. I mean, this is has 1/4 inch thick stock. I cut it in two halves, and this essentially straddles inside the housing like so. That is designed to go there, and for this rod to pass through into there to place a nut on. And snug this down pretty tight, okay, so that's the unit in its full glory, so to speak. Then once it's in and preloaded, I remove this nut here. Now that that is off, then this bar, this I think this 1/2 inch piping goes on there, and then the strike area here, and then what that enables for the shock to hit this and not just the bar, but hits where it needs to hit and send the shock straight down to these fingers, and then taking out the race. So let's get that loaded into the unit and see how it works. And then we've cranked it down. I did that and engaged the inner race right on that lip there, and then we've fitted our bracket here, and I've taken up the tension with a breaker bar. So I put a fair bit of tension on that now, so we've got a good grip on those. That is on there right now. They're engaged. I don't know whether I can get deep in here. So the fingers are all the way around, all 6 of them engaged on that race. And we're going to strike this, see if we can get these races moving. I think it shifted it. See? Our holding device is loosened, so what that tells us is that it's working. So I'm going to tighten it up again and keep the tension on those fingers, like so it's preloading it, so to speak. Yeah, that's done that well. So I bring up the tension again. not in a hurry. You can see the race coming out here, and every time I hit it, this thing gets looser, essentially. And so we know we're good, don't we? Well, we're out. We've got our inner race, and I'm just checking for any damage. That's the main thing, isn't it? That's why we're doing all this. Now this has come out fine, but we were hitting on the shim, weren't we? So let's check the shim condition. We've got a few little scratches on the shim, but this has come out actually better than I was expecting. When it comes to the solid axle, same thing applies. There's a shim underneath this bearing race, and this is obviously going to adjust the backlash. This adjustment, you know, if you put a fatter one in, a thinner one in, and then take it up with the nut on the other side. But you're going to have to be able to get this race out, in and out reliably without damage. And I do believe with a little adjustment, take this one off, you would have to make a slightly different one of the same principle with the arms at a slightly different angle. If you can see here, this would go in like that, and you can see that, if you can see on camera there, just balance it in there, you can see the orientation of this race. It flares out at the end. So these arms, I think maybe if you did a shorter arms where they flare out at a sharper angle, and they're going to have to do a bit of playing around with, experimenting with lengths and everything, and then making sure these fingers are cleaned and burnished up enough to catch that lip. And then what I would do, I was thinking about this in bed last night, this thing, let's take that out, this yoke thing, again, this one would be a little small for this race, because you want the ability for the race to come into this area, and you obviously you don't want to space it out here, you don't want to stress this casting, you want to be on this ring, this strength area here. So just a question of getting some solid pipe that would rest on that. And then what you could do is crank it, preload it, and then just have a very long piece of this rod, or a long bit of 1/2 inch, essentially, wouldn't you? Wouldn't need a long bit of that. You just need a long bit of this to come in and put the pressure right on that point, not on here. That, I think, was key to make sure to send as much shock down those drift legs as much as possible. So now we're successful in doing that. I wanted to show you the setup on the outer side. Now we've kind of deactivated it. I took the washer out, and I'm going to bring this rod a little longer because we're going to be pulling this way, you see. So, and I may, because the access of striking it inside is back to the old problem again, is that we can't get a hammer strike inside here. So we're going to use the impact hammer on the end of the rod, and we should be able to get enough force to be able to pull that guy out. Washer in first. Could load it up on the outside. And that's why I say we can have longer bushings. It's starting to hold itself in now. That's essentially centralized itself automatically, you see. And so I preload it, get that loaded up. You could probably use a crow's foot as well. Get right in there. I'll get you a good shot of the engagement. Get some good tension on those. So they're forced into the corners. So that's on there now. There you go. You can see it in there, all 6 legs wrapped around. There you go. That will go on there. Now, I've not done this again. I've not tested this. You are the first. I get the more powerful impact hammer. There you go. There's the race. Let me try and hold that while we... And we're very nearly out. I just want to make the observation is that, like I say, we've preloaded and those fingers are pushing on the walls there and hold it into position, and that's what makes it really work nicely. There you go. So you can see the amount there spread out there, really spread out now to get, shows they've sprung out now, they've got no wall to press against. About improvements on the tool, I think there's one improvement I'd like to make is instead of a washer down here pushing the fingers apart, a tapered, something tapered would work better. Now I can turn something on the lathe out of wood because say solid oak or something like that, on a cone shape with a hole drilled through the center and waxed and oiled and everything, and that just needs to slip between those fingers and just force its way out. You see, that's not going to break if you use a solid piece of oak or something like that, hardwood. That'll be perfectly adequate, because this washer, it goes down perfectly fine if you lubricate it and chamfer the edge, but that's just a little refinement. This worked awesome. With some simple pieces of material you can pick up at any hardware store: 1/2-inch rod, 1/2-inch nuts, washers, connecting bolts, sleeves, whatever they call them, little 3/4-inch bar. I did reinforce this bar at the top, just I added a bit of 1/4-inch plate on the top just for my, I don't know, I was just getting into the welding that night, I guess. 1/4-inch curved pipe here, and then these fingers. And you know, if you don't have a welder, I wouldn't mind betting you could get a welding shop to weld you one up, you know, because I'm not an experienced welder, and this took me probably about 35-40 minutes to weld up and grind and make look halfway decent. A good welder do it in 20-25 minutes, I'd imagine. And then a 3/4-inch bit of pipe for the striking action, and you'll be good to go. Well, that was a major hurdle across today. I'm very happy the way it worked out. One of the big holding points with this job is to be able to make your adjustments. I mean, figuring out what adjustments you need to make, but being able to carry them out, i.e. removing the shim, removing the races, putting different shims and putting the race back in, rechecking with all the gear paste, reassembling. And you could really start to see why certain shops don't want to deal with this. It's not that they, I don't think, couldn't do it, it's just that it's very time consuming. And I think for a lot of shops and mechanics, they're on a hourly rate, you know, and something like this is going to eat up a lot of time if you're not used to doing them. So yeah, learned a lot today, and I hope this was helpful to people. And so what I did want to show you, we got some bearings and parts from Classic Center. I chatted to Duke, and no brainer really, just go for the name brand Mercedes. These are Timken, I think made in France, these one. We got a couple of kits for the seals at the end. We got the axle bearings that I'm going to review and show you what they're all about on the 6.3. Got pinion seals. We got 2 crush washers in case we screw one up. They're only about $7. So when we go to preload that bearing, if I go too far, we've got another backup. So I thought that was wise. And I got 2 pinion seals because my 280 SE is leaking a little bit, and so I'm going to have to tend to that. Also I've got 2 pinion nuts as well, replaceable nuts. I was of the assumption that the outer sleeve were replaceable, but Ron in Australia informed me no, they come as 1 unit, which he's obviously right. So there we go, 2 of those guys. And if you can see there, they're pinned in there, so that sleeve can't rotate around the nut, and then when you get it to the right position you just pin it into the flange so it doesn't back off on itself. But I'll go over this little lot next time in the next video. Thanks a lot for watching, guys. Really appreciate it. Really appreciate all the help that I've been getting, all the encouragement. It's been a lot of fun doing this, and I will see you in the next one. Please hit subscribe, like, share, all the business, and have a good one. Take care. Bye bye.